Kia ora. Let's look at how to draw enantiomers. Now remember, enantiomers, they have a chiral carbon with 4 different groups, so it has a tetrahedral shape. So to draw a tetrahedral shape, you draw 2 bonds in the plane of the paper, so they're just straightforward ordinary lines at approximately 109 degrees, and then you will have a wedge coming towards you, which we draw as a solid wedge. The thin end is by the chiral carbon and the fat end is towards you. And then we have a hashed wedge where the fat end is by the chiral carbon and it disappears off into the point, to a point, because that is going away from you behind the paper. So let's draw the enantiomers for butane 2-ol. So we have carbon and we draw the 2 in the plane. So make sure that your bond angle is approximately correct. Then we have a solid wedge. I've made a little bit on the big side, but it's still possible. And then we have a hash going towards a point. And if it's butane 2-ol, this chiral carbon is the second carbon, with the 4 different groups being a methyl and an ethyl, because, whoops, CH2, CH3, because those are your 4 carbons in a row, and then the OH, and then the H. So that's butane 2-ol, with that second carbon being your chiral carbon. So if I want to draw the enantiomer, I draw the mirror image. So here I had the 2 in the plane, the 2 bonds in the plane on the left-hand side. So here I have them on the right-hand side. And then I put my wedge on this side and my hash going to a point behind. Now, when I connect my ethyl group, I've got to make sure I don't have my CH3 attached to the chiral carbon. Otherwise, that carbon will have 5 bonds. So I need to have CH3, CH2 being attached to the chiral carbon, and then the hydrogen over there. So those are the 2 enantiomers. Common errors is not having your bond angles correct, where you might draw something like this. That is a big no-no because your bond angles aren't correct. The other error is often students connect atoms incorrectly. So say, for instance, they were wanting to do this butane 2-ol, and they did the OH over here, and they wrote OH like that. That means the hydrogen is bonded to the oxygen and the carbon, and hydrogen can only form 1 bond. So that would be incorrect. Oops. The other thing I wanted to show was if we had this system, it's another way of drawing a tetrahedron where we've got wedges coming out, and we've got 2 bonds going into the plane. So we'd show them as hash going into the plane. And a lot of students find this easier because it's all 90 degrees. So for my butane 2-ol, I draw my 2 wedges coming out, and my hash going in. Remember, the hash, the point is always away from the chiral carbon. So I'd have OH, CH3, CH2, CH3, and hydrogen. And when we want to draw the enantiomer, then we just swap a pair. It can be any pair. So I'm just drawing my hash and my wedges. So I could just simply swap my hydrogen and my methyl. So I could have my methyl there and my hydrogen on my right instead of on the left as over there. But that means I've got to keep the OH and the ethyl in the same position, OH on the top and the methyl at the bottom. If I swapped it around, if I had, those are my wedges and those are my hashes, if I swap those 2 around where I had the methyl and I've had the hydrogen on that side, and I swapped the OH and the CH2, CH3, so now I've got the CH2, CH3 at the top and the OH at the bottom, then this is not an enantiomer. This is identical to the molecule on the top left. So just be careful, only swap 1 pair. So if I now look at some examples, are these enantiomers or not? These are enantiomers. because we've got our H and OH on the right-hand side here, and here they're on the left. So they are a true reflection, and I've correctly written my OH. These are not enantiomers, because remember, enantiomers must have a chiral carbon with 4 different groups, and this one has got 2 hydrogens. So these are not enantiomers. These are enantiomers because I have swapped the hydrogen and the methyl, and I've kept the bromine and the ethyl the same. And these are enantiomers because what I've done here is I've swapped the hydrogen and the ethyl. So I've swapped that pair around, and I've kept the others the same. So hopefully you can now draw enantiomers. Kia ora.